Hi, welcome to 3.2. You need to get your energy notes out so that you're ready. We are on section 3.2 of your notes. Section 3.2 of your notes. So let's get started. Your first question is, what is work? Well, work is defined as using a force to move an object a distance. Using a force to move an object a distance. But note the bottom line down here, when both the force and the motion are in the same direction. So think about carrying something. It takes effort, it takes strength, but it doesn't take scientific work. You did the scientific work when you lifted the object up because the force and the motion were in the same direction. In the second box, you've got the formula and relationships for work. The formula for work is equal to force times distance. And you need these units. Work is measured in J or joules. Force is measured in newtons, and distance is measured in meters. Be sure you have the units. But the relationships, you can draw this. Remember that if it's across the equal sign, it is a direct relationship. And if it's on the same side of the equal sign, it has an inverse relationship. So on your formula sheet, right, it's on the back of the yellow. On your formula sheet, you need to copy down. In 3.2a, work is W is equal to F times D, and it's measured in joules. Remember this first column that has the words in it, work, this is what you're trying to find, work, force, or distance. This is what you do to find work. You take force times distance. And this is what things are measured in, what the units will be at the end. Be sure you get the formula and the relationships written down. Be sure your formula sheet gets filled in as well. Let's look at an example. In your notes, it says, if a man pushes a concrete block 40 meters with a force of 100 newtons, how much work, key question, has he done? Remember that work is equal to force times distance. The force given in the problem was 100 newtons times a distance of 40 meters will be 400 joules of work. 400 joules of work. Again, if a man pushes a concrete block 10 meters with a force of 20 newtons, how much work has he done? Work is equal to force times distance. 20 times 10 is 200 joules. I don't always need to just find work. Sometimes I have to find force. Force is equal to work divided by distance. And sometimes you'll need to find distance. Distance is work divided by force. So the next section of your notes is on power. Power is the rate at which work is done, and power is a force that can change a velocity. Power is the rate at which work is done, and power is how a force can change a velocity. So your basic formula for power is work divided by time, and you need the units in the box that says formula and relationships. Power is measured in units called watts, and I would not at all recommend that you abbreviate that to be a W because you already have a W in the problem. Work is measured in joules, and time is measured in seconds. And you need on your formula sheet, or I'm sorry, in your notes, the relationships. if power is work divided by time, then believe it or not, power and work are directly related. Power and time are inversely related. So these are the same equation, just rewritten into our format so that we can see those relationships easier. On your formula sheet, you need to write down the equations for power, work, and time. But remember, power is also a force that can change velocity. So power is also force times velocity. Force and velocity have their own rewrite equations. Be sure you get all of this listed on your formula sheet. So let's look at a problem in your notes. What is the power rating of a machine that can do 16,000 joules of work in 5 seconds? Remember, you're looking for the what is or how or calculate question. So we're looking for power. Power is work divided by time. 16,000 divided by 5 is equal to, grab my handy dandy calculator, 3,200 watts. And again, don't abbreviate it as a W. And also, because we're still looking at power, power is, what is the power rating of a machine that can apply 750 newtons to move an object at 3 meters per second? Power is equal to force times velocity. Force in this problem is 750 times 3 meters per second is equal to 2,250 watts. Let's look at some other examples. So power rating a machine that can do 6,000 joules of work in 15 seconds would be 400 watts. Work, how much work can a 350 watt machine produce in 30 seconds? And we could also use this to find time. So this is a really cool relationship. You, in your notes, again, in your notes, this is force to work to power. So way back in Unit 1, when we studied force, and you will want to keep that formula sheet available, force is equal to mass times acceleration, right? And work is equal to force times distance. So I could actually substitute this mass times acceleration in here for force, like you would substitute French fries for mashed potatoes. So that work could be mass times acceleration times distance. Work makes me mad. Mass, acceleration, and distance. And we know that power is work divided by time. So power could be force times distance divided by time. Or power could be mass times acceleration times distance divided by time. Power makes me mad over time. All of the relationships that you have learned so far this year all go together, and you have to keep remembering them. So let's look at a big practice question in your notes. Big example. It says a 300 kilogram object is accelerated at 1.2 meters per second for 5 seconds, a distance of 12 meters. How much work was done? Well, I know that work is equal to force times distance, but I don't have a force in the problem, but I do have a mass and acceleration. So force is equal to mass times acceleration, right? So my mass of 300 times my acceleration of 1.2, again, grab your handy dandy calculator, is 360 newtons, right? But then I'm going to take that answer and I'm going to put it in here for force, so that work is equal to force times distance. And my force is 360 that I just found, times my distance in the problem of 12 meters. So 360 times 12 is 4,320 joules of work. So that's the first part. How much work was done? 4,320 joules. You could have also used the equation work makes me mad, mass times acceleration times distance. And the mass of 300 times the acceleration of 1.2 times the distance of 12 is still 4,320 joules. Then it says how much power is required. Power, remember, is work divided by time. So if the work is 4,320 divided by a time of 5 seconds, then my power is 864 watts. 864 watts. Look at another example. How much work is done to push an object 7 meters across the floor with 50 newtons of force? Well, remember, work is equal to force times distance. So if we push it across the floor and back again, we actually went 14 meters instead of 7. How much power was required to do that in 20 seconds? That would be 35 watts. You're going to have more problems like this in class today. Thanks for watching.